All right. So, guys, welcome to the last session for this gate preparation journey of ours. And this is going to be week 23, part 2. Okay. And previously, in yesterday's session, we discussed 4 questions. Last question, I took it from today's session for yesterday because we had some time. Today we are going to discuss 3 questions, 3 gate questions, and some more questions to just solidify the concept. So the first question is going to be on matrix. Second question going to be on some functions. Third question will be again on matrix. So this is just a simple matrix basic concept. This is related to eigenvalue, and we are going to see some more side questions to solidify the concepts. Okay, so these are all the yesterday's questions. Hope you have seen the video. Now let's come to the today's session. Let's start today's session. So GATE 2009 question number 1. A square matrix B is skew symmetric if B transpose is equal to minus B, B transpose is equal to B, B inverse is equal to B, B inverse is equal to B transpose. Okay, so we all know that what is a transpose, at least we know that, right? So if we have a matrix which is 1 2 3 and 4 1 2, let's just write some matrix randomly, then the transpose of this is just the rows and columns are shifted, right? This is the transpose. What was symmetric matrix? Symmetric matrix was when we have the transpose is equal to the matrix itself. So if we had 1 2 1 2 1 4 1 and 1 and 5, then when you transpose this, you will realize that this, when it comes here as 1 2 1, it is same as this column, right? Similarly, if you do for the other things, 2 4 1 1 1 5, it is going to be the same. So when A transpose is equal to A, then we call it as symmetric matrix. What is skew symmetric? Skew symmetric is when we have A transpose is equal to minus A, right? So let us see. Let me write here one matrix, and I want to know from you guys whether that matrix is skew symmetric matrix or not. So the matrix is 1 minus 2 minus 4 2 2 0 4 0 1. So tell me whether this matrix is skew symmetric matrix or not. Okay, so let's do the transpose and we'll see. So when we are wanting to do the transpose, what we'll do? We'll take this column and put it into the row, right? So let's do that. 1 minus 2 4 and 2 2 0 4 0 1. What do you guys think? See, like previously in the symmetric matrix, this came here, this was here, this was here, and everything was same. Here also it looks like that, no? Like 2 is replaced by minus 2, right? From here minus 2 replaced by 2, minus 4 by 4 4, right? So what do you think? 4 by minus 4 minus 4 4 0 0. What do you think? Is it skew symmetric? Those of you who are thinking that it is skew symmetric, you are missing major thing in this question, that is the diagonal. See, when you perform the transpose of a matrix, the diagonal elements don't change, right? So, in case of the symmetric matrices, the diagonal elements don't matter when we are trying to check whether the matrix is symmetric or not. In case of skew symmetric matrix, they have a lot of value. So, if you think, what is the possible way, what is the possible value that we can give to these diagonal elements so that this matrix becomes a skew symmetric matrix. So whatever we want to do, we have to do something like minus a has to become a, right? So what does that mean? We can shift this a to the RHS of the equal to sign. So 0 is equal to 2a. So a is equal to 0, right? So the diagonal elements, the value of the diagonal elements in case of skew symmetric matrix is always 0, right? So aij for I equal to j is 0 in case of skew symmetric matrix. Sometimes when we are in a hurry, we can do these kind of mistakes. So option A is correct. All right, so now you guys tell me whether this is a skew symmetric matrix or not. It is not, right, because even though these two are 0, this is not 0. So even though all the other elements are going to satisfy that criteria, because of this alone element 1 being not 0, because it is a diagonal element, A transpose is not equal to minus A, right? How about this one? How about this one? This one is a skew symmetric matrix, right? So if you just do the transpose, you will see all the elements have become the negative of each other, and diagonal elements are 0, correct? So I hope you understand this difference between the skew symmetric and symmetric matrix and what makes the skew symmetric matrix so special. That is, the diagonal elements are always 0. Okay, so that's all for this question. Let's go to the next question. GATE 2009 question number 3. So we have an analytical function fz is equal to z minus 1 divided by z square plus 1. This function has singularities at z is equal to 1 and minus 1, z is equal to 1 and I, z is equal to 1 and minus I, z is equal to I and minus I. So this is a very simple question. Just you have to remember that z here is a complex number that is written as x plus iy, where this is the real part and this is the imaginary part, right? Now, when you have a function, let's say in terms of x, and you have some expression gx divided by, um, let's say wx, this will have singularity when the function is not defined. or the denominator is 0. Denominator tends to 0 or is 0. So to get the solution for this question, we have to put the denominator of this expression equal to 0. Remember that z is a complex number. Now, can you solve this question now? Many of you would have already solved this question, but let's just uh, try to see what is the value that we get. Z square plus 1 is equal to 0. So if we simplify this, what will we get? Z square is equal to minus 1. And what do we know in complex? That in that the root of minus 1 is not defined. That is the whole basis of complex. Root of minus 1 is plus minus I, right? So the answer for this question is going to be z can be I or minus I for this denominator to be 0, and correspondingly the function fz is going to be singular index. So option D is correct. Okay, so I hope that was clear. Let's go to the next question. So GATE 2008 question number 26. The eigenvalue of this matrix P, square matrix, which is given as 2, 4, 2, 5, minus 5, are options are given minus 7, 8, minus 6, 5, 3, 4, and 1 and 2. So how do we get this eigenvalue of a matrix? We get it by solving the characteristic equation, right? How do we get that characteristic equation? We put the determinant of P minus lambda I is equal to 0. So let's write that here. 4 minus lambda 2, 5 minus 5 minus lambda is equal to 0. Now why only we subtracted the lambda from these diagonal elements? Because this lambda is multiplied with the identity matrix, which has only the diagonal elements as 1 and other elements as 0. So lambda I is nothing but lambda 0, lambda 0, right? Okay, so now let's write the matrix. So we have 4 minus lambda minus 5 minus lambda minus 10 is equal to 0. So let's try to simplify this. We have minus 20 plus 5 lambda minus 4 lambda plus lambda square minus 10 is equal to 0. So lambda square plus lambda minus 30 is equal to 0. So we can get the hint of what is going to be the answer, right? So lambda square plus 6 lambda minus 5 lambda minus 30 equal to 0, and the answer is lambda can be either minus 6 or lambda can be 5. We can do the factorization and you can get the values, right? So lambda plus 6 here, and then minus 5 lambda plus 6. We can write this quadratic equation in terms of these two root factors, and then we can get the value, right? So the eigenvalues are minus 6 and 5. So option B is the correct option. Now, what else can we learn from this? So can I say that my matrix P satisfies this equation? P square plus P minus 3I is equal to 0. Can I say this? We can say this, right? Because from the Cayley-Hamilton theorem, we know that the matrix satisfies its own characteristic equation. So when we put determinant of p minus lambda I is equal to 0 and we got the equation for the eigenvalues, that is lambda, in between that we can see that this quadratic equation of this lambda, which is the characteristic equation, if we replace the lambda by this matrix P, and then for the constant we have to multiply the identity matrix, then we can say that this equation is valid, right? So people can get, you can get these kind of questions. So they will give, in fact, next two questions that we are going to see are going to be related to this only, that you will be given one matrix, 2 by 2 matrix for simplicity, and then I will ask you to tell me what is the equation that this matrix satisfies. And also based on this, if they want to increase the complexity little bit, they can say what is the value of p cube or p power 4. So how to approach these kind of problems? So if you know this, you write p square is equal to 30i minus p, and then p power 4 is nothing but p square into p square. So you will have 30i minus p into 30i minus p, and then you solve this and get some expression, but in the end again you will be left with p square here by this multiplication. Then you go back and substitute this here, so till you get the expression in terms of just your I, some constant I and some constant p. So like that you have to approach this kind of question. So what can they do? They can either give you the options as just as the matrix, some values here, some values here, when they ask you what is the value of p power 4, or what they can do, they can give you the expressions in terms of constant with the identity matrix and the given matrix. All right, so let's see one of these questions. Before we go to that question, let's just see whether you can tell me quickly what is the eigenvalue of this matrix. Can you guys tell me what is the eigenvalue of this matrix? So this question does not even need you to pick your pen, right? Why? Because this is a upper diagonal matrix. And what are the eigenvalues in case of upper diagonal matrix? The diagonal values are the eigenvalues, correct? If we want to prove, let's try to prove that. So let's say this matrix is A, and A minus lambda I is equal to 0. So we are going to solve this determinant equal to 0 to get the eigenvalues. So let's try to solve. 1 minus lambda, 2, 1, 3 minus lambda, 4 minus lambda, 1, 0, 0, 0. Now what did I tell you? In previous math sessions, I have told, and also you guys also shared with me, that you know that when we are trying to calculate the determinant of a matrix, we can expand the matrix along any column, any row, right? So I'm going to make my life easy, and I'm going to expand this matrix to get the determinant from this for this column along this. So this is 0, this is 0. We only need to worry about the first element, 1 minus lambda, and then this minor, 3 minus lambda into 4 minus lambda minus 0 into 1, 0, that is equal to 0. So what is the characteristic equation? 1 minus lambda, 3 minus lambda, 4 minus lambda is equal to 0. So then in that case, what are the eigenvalues? Eigenvalues are lambda is equal to 1, 3 and 4. What are these values? These values are the um, diagonal values of this upper diagonal matrix. Similarly, in if you have lower diagonal matrix also, this condition will apply. Okay, so these kind of trick questions which you can solve if you remember some of the properties may come in your gate examination. Okay, now let's go to the question that I was talking about related to the matrix and the characteristic equation, or you can say the Cayley-Hamilton theorem. Okay, so I don't have space here. I'm going to erase this because I just wrote that to make a point. So yeah, let's write this equation. So suppose that you have a matrix A is equal to -3, -1, 2, 0. Now, first question, out of which of these equations do you think the matrix satisfies 1? So we have A plus 3i minus 2a inverse is equal to 0. We have a square plus 2a plus 2i is equal to 0. C, a plus I, a plus 2i is equal to I, and D, exponential of a is equal to 0. So when you see these type of questions, just immediately understand that the question is asking you to get the characteristic equation of this matrix. So let's try to get the characteristic equation. So -3 minus lambda, 0 minus lambda, 2 minus 1 is equal to 0. So -3 minus lambda into minus lambda minus of -1 into 2 is equal to 0. So I'm not writing the step that first we are doing determinant of a minus lambda I is equal to 0. I have directly written it here. And when you try to solve this, you will get 3 plus lambda into lambda plus 2 is equal to 0. So lambda square plus 3 lambda plus 2 is equal to 0. So if we replace here lambda by a and then the scalar by we multiply with the identity matrix, then we will have a square plus 3a plus 2i is equal to 0. Do we see this expression here? We don't see this expression here, right? So what can we do? We have to look carefully whether this kind of this expression can be modified, or can we do some kind of factoring to get that. So let's try to get the factors. What are the roots for lambda? So we can write lambda square plus lambda plus 2 lambda plus 2 is equal to 0. So lambda plus 1 into lambda plus 2 is equal to 0. We can write this quadratic equation in terms of these factors, right? So can we, when we replace this lambda by this a, can we get something similar in the option? Let us see. A plus I into a plus 2i is equal to 0, not I, right? So option C was very much close to what we are trying to get, but we didn't get that. And option B is not at all there, option D is not at all there, option C also got crossed, option A only is remaining. So let us see, can we get this option A from this expression? So we have a square plus 3a plus 2y is equal to 0, but here we have a plus 3i plus 2a inverse is equal to 0. So you can already get a hint of what we are going to do here, right? We are going to multiply with a inverse to this expression. So when you multiply a inverse with a square, one a will get cancelled and become identity. This will be a. Here it will become identity and I, and here we will have 2a inverse, and then multiplication with 0 is 0. Now you see that you have the correct option A as arrived from this given equation, right? What they can do if they want to make tough examination paper, they can even multiply this question with A. So even if you have, like, if you have A square here plus 3A plus 2I is equal to 0, they can just multiply another A here and still it will be 0, right? Then what you have to do? You will have A cube plus 3A square plus 2A is equal to 0. And then this A square will again come from this expression. Lot of tricks they can do, but just remember that everything is going to be related to your characteristic equation for the matrix A. All right, so you can play around with this and get some other expressions, but let us move to the next question. That is, if you know all these things, what is the value of a to the power 9? Second question is going to be, what is the value of a to the power 9? In this case, I am going to give expressions instead of one matrix so that we don't have to do a lot of calculation. We still have to do some calculation, but not a lot. So option A, 511A plus 510I. Option B, 309A plus 104I. Option C, 154A plus 155I. Option D, exponential of 9. So one thing we know that this is not at all going to be the option, right? This kind of elimination you can clearly do that. Option D is no chance that it is going to be so. But which of the three options is correct? To do that, unfortunately, we are going to have to do some calculations. So let us see what type of calculations we have to do. See, we have a square plus 3a plus 2I is equal to 0. Now, we can write a square is equal to minus 3a minus 2I. Correct? Now, can we get a power 4 from this? Yes, we can get a square into a square. So, minus 3a minus 2I into minus 3a minus 2I. This, if you do the simplification, you will get 9a square plus 12a plus 4I. And you have to again substitute the value of a square from this expression into this equation. And what you will get finally, I'm going to write after all the calculation what we get in the end. We will have minus 15a minus 14I. So this is your a power 4. Now when you know a power 4, we can get a power 8 by multiplying two of these, right? So I'm going to remove this minus sign because it is going to come in both of these. I hope you can follow this because we are going to multiply this again, right? So if you take minus common here, you will have minus minus and you can remove that uh, minus sign from here. Okay, now when you do this, you will have 225a square plus 420a plus 196I. Again, you have to substitute the a square from here in this expression. And finally, you will end up with minus 255a minus 254I. This is the value of a power 8. When we know a power 8, now again we can get a power 9 by multiplying this with a. So 255a minus 254I into a. So what we'll have? We'll have minus 255 a square minus 254a. What you know already what we have to do? We have to substitute the a square value from the characteristic equation here also. And finally, in the end, what you will end up with? a power 9 is 511a plus 510I. This is going to be your final answer in this case. So the correct option is going to be option number A. Okay, so this is how you are going to solve these kind of questions. See, if you feel that this is too lengthy question and these kind of questions will not come in gate, then you are wrong because this is not a civil engineering question, but this is a gate question for electrical engineering that came in 2008 or 9. I don't remember the year exactly, but I could not use this question in our quota scheme because we are only restricted to civil engineering. Still, I want you to be aware that these kind of questions are also there and they can come in civil engineering also. Okay. All right. So that's all for this session. And as I said, this is the last session for our GATE preparation previous year question solution. So because your GATE exam is on 4th of February, so I hope you have solved lot of test series and you have looked at lot of previous year questions. I know we have looked here at least 70 to 80 questions. I hope that they were of some help. I know some of my colleagues were taking environmental engineering and other subjects. So I hope you followed them and all the best for your examination. All right, thank you.